It is a cold, gray afternoon in the Normandy countryside, June 8, 1944. 24 hours have passed since the beaches fell silent, and the bocage, that tangled maze of hedge and sunken lane, has become a graveyard for the unprepared. A German Panther tank, 36 tons of armoured menace, grinds its way down a narrow track towards a British defensive position. The afternoon light catches the dust rising behind it. From the hedgerow ahead comes a dull, metallic clunk, a sound entirely unlike the roar of aircraft engines or the sharp crack of rifles. What followed that sound would have been impossible to predict just 18 months earlier. Within seconds, the Panther erupts in flame. The shot that did this came not from a heavy anti-tank gun requiring a team of 6 or 8 men to operate, but from a device so compact, so revolutionary in its conception, that many soldiers refused to believe it actually worked. This is the story of the PIAT, the projector, infantry, anti-tank, and how a small group of engineers and ordnance experts created one of the Second World War's most audacious weapons. Before the PIAT existed, the problem of stopping tanks was an almost metaphysical one for British commanders. In 1940, after the catastrophe in France, the British Army possessed precious few answers to the question of how ordinary soldiers, equipped with nothing more than rifles and grenades, might disable a German tank. The boy's anti-tank rifle, a weapon dating from the 1930s, could penetrate the thin armor of early tanks, but by 1941 it had become virtually obsolete. German tank designers had responded to reports of these rifles by simply adding more armor. The 37mm shells that could stop a Panzer IV in 1940 bounced harmlessly off the Panzer Vs and V as that appeared by 1943. Britain's much-vaunted 2-pounder anti-tank gun, mounted on its wheeled carriage and manned by a crew of 4, required a 2-ton truck to move it across rough terrain, could not be easily concealed, and, most critically, was far too scarce. There were only so many such guns, and they were needed at the coast, in the desert, in every theater at once. The men at the Ministry of Supply and those working in the ordnance research establishments knew this was unsustainable. If the infantry soldier going into battle had no personal weapon capable of engaging tanks, then the tank would become truly supreme on the battlefield. Worse still, the Germans were adding armor to their tanks almost monthly, seemingly locked in an endless arms race that the British, with their overstretched manufacturing base, could not win through conventional means. The solution, if one existed, would have to be different in character from everything that had come before. It would need to be cheap to manufacture, light enough for a single man to carry and fire, concealable, and above all, it would have to work against progressively heavier tanks. The very idea that such a weapon could exist seemed almost fantastical. The inspiration came, curiously enough, from the Americans, though the British would develop the concept independently and more thoroughly. In 1942, the Ordnance Board began examining the theoretical advantages of a spigot mortar principle applied to an anti-tank weapon. Imagine a long rod, a spigot, running through the center of a mortar bomb. That rod sits inside a spring-loaded barrel. When the projectile is fired, the spring propels the entire bomb forward, whilst the spigot remains stationary, anchored to the weapon itself. This means the bomb travels over the spigot, leaving it behind. The principle is elegantly simple, yet its applications were radical. A spigot mortar could be far lighter than a conventional cannon because it did not need to withstand the pressure of an explosive charge detonating within a sealed breech. The mortar fired by spring action alone. The man primarily responsible for translating this theory into a working weapon was Major Jeffers, an eccentric and brilliant ordnance engineer working at MD1, the Ministry of Supply's experimental weapons establishment based at Whitchurch in Shropshire. Jeffers, assisted by a small team of engineers and draftsmen, began designing what would eventually become the PIAT in early 1942. The weapon needed to throw a hollow charge warhead, a shaped charge projectile that could concentrate the force of its explosion into a narrow jet capable of burning through tank armor. The technical challenge was formidable. The bomb itself would weigh roughly 4.5 kilograms, roughly equivalent to 2 kilos of high explosive wrapped in an ingenious metal shell designed to focus that explosion into a superheated stream of molten metal, traveling at speeds exceeding 2,000 meters per second. The barrel required no rifling, no complex breech mechanisms, none of the engineering sophistication demanded by conventional anti-tank guns. The PIAT, as it eventually appeared, weighed approximately 14 kilograms unloaded. To fire it, a single operator would need to push the heavy rubber butt plate hard against his shoulder or hip. Inside, the weapon sat a powerful compression spring, a spring so strong that loading the device required genuine physical effort. You would place a projectile into the muzzle, push it forward to engage with the spigot, then manually cock the spring mechanism by pushing downward on a cocking lever. This cocking lever was perhaps the weapon's most distinctive feature. It required significant force to depress, demanding that the operator either lean hard against the weapon or brace it against terrain. Once cocked, the trigger assembly was ready. Squeeze the trigger, and the spring released its stored energy, propelling the bomb forward at a muzzle velocity of roughly 90 meters per second, slow by the standards of a conventional gun, but sufficient to penetrate the frontal armor of most German tanks from ranges up to 100 meters, and weaker armor at considerably greater distances. The manufacturing process began at the factories of the Blackburn Aircraft Company in Leeds, though production was later expanded to include several other manufacturers. The weapon's simplicity, compared to traditional anti-tank guns, meant it could be manufactured by firms without extensive ordnance experience. The spigot itself was a precision-engineered steel rod, but the barrel was essentially a tube. The firing mechanism involved relatively few components. By 1944, production reached respectable numbers, with thousands of PIATs being manufactured annually. The exact figures remain somewhat opaque. Records remain classified regarding total production volumes, but estimates suggest that somewhere between 7,000 and 8,000 PIATs were produced by the time of the German surrender in 1945. The weapon began to see operational use in 1943, initially distributed to specialist anti-tank squads attached to rifle companies. By the time of D-Day in 1944, every British rifle company carried PIATs. The Normandy campaign saw the weapon used extensively in a role for which it proved uniquely suited, the defense of hedgerows and sunken lanes. A single soldier, concealed in a ditch or behind a hedge with his PIAT loaded, could engulf the landing of a German armored column. The Germans, accustomed to tanks that were nearly invulnerable to anti-tank rifles, were deeply shocked by the effect of the shaped charge warhead. Veterans' accounts, where they survive, describe shock and anger. How could a single infantryman, apparently armed with nothing heavier than a rifle, destroy a Panther? The tank crews soon learned to respect the weapon, developing tactics to counter it, but the psychological impact was immense. If you are finding this interesting, a quick subscribe helps more than you know. The 2nd Battalion, Welsh Regiment, defending a position near Lingham in July 1944, recorded the destruction of at least 2 German tanks using PIATs. Witnesses described the moment of impact, a flash of light far brighter than a rifle's muzzle flash, then a column of smoke erupting from the engine decks of the tanks. In Northwest Europe generally, anti-tank squads equipped with PIATs became renowned for their lethality in defensive positions. The weapon's slow muzzle velocity meant it required a longer flight time than conventional anti-tank guns, making long-range shooting considerably more difficult, but within its effective range, it was devastatingly effective. An operator who could see the target, who had a secure firing position, and who possessed reasonable skill at range finding, could reliably penetrate and destroy the vast majority of German tank types. The Panther and Tiger tanks, despite their formidable armor, possessed weak points: the engine decks, the turret rings, the sides and rear, where the shaped charge could do catastrophic damage. The Americans were impressed by the PIAT and briefly considered adopting it, though ultimately they persevered with their bazooka, a rocket-based system that proved problematic, but which American industry had already committed to manufacturing in enormous quantities. The German response was the Panzerfaust, a disposable single-shot shaped charge projector that in many respects surpassed the PIAT in terms of pure practicality. Whilst the PIAT was reusable and required logistics support in the form of ammunition supplies, the Panzerfaust was a one-time use weapon that required no complex mechanisms, no cocking leverage, simply point, shoot, and dispose. By 1945, hundreds of thousands of Panzerfausts were in circulation amongst German infantry, and they would become the template for post-war shaped charge infantry weapons across the world. In this sense, the Germans, learning from the British innovation, produced a more elegant solution. The Soviet shot, developed in parallel, was likewise a spigot mortar design, though it too never achieved the production numbers the Panzerfaust eventually managed. Compared to the American bazooka, the PIAT was more reliable at penetration, though the bazooka's shaped charge was more destructively focused. The British weapon was heavier, slower to reload, physically exhausting to operate, and required considerably more training to use effectively than either the bazooka or the Panzerfaust. Yet it offered something they did not: absolute reliability through mechanical simplicity. A PIAT never jammed due to electronic failure, never suffered misfires through chemical instability. It was operated by muscle and will alone. The weapon's actual combat effectiveness remains somewhat contested by historians. Tank losses from anti-tank rifles and infantry portable shaped charge weapons were real, but they represented only a fraction of total tank losses on the Western Front. Artillery, anti-tank guns, aircraft, and tanks engaging other tanks accounted for vastly more armored vehicle losses. Yet the psychological and tactical impact of the PIAT was disproportionate to its accounting on casualty rolls. German tank commanders knew that any position defended by competent infantry was now infinitely more dangerous. The requirement to operate in close cooperation with infantry, to avoid being surprised in hedgerows and built-up areas, fundamentally altered how tanks had to be deployed. In this sense, the PIAT changed mechanized warfare itself. The post-war years saw the shaped charge principle refined, standardized, and eventually weaponized in forms that the inventors could scarcely have imagined. The portable anti-tank weapon of the 21st century still relies on principles Jeffress and his team first applied to the PIAT. The weapon itself, rendered obsolete by advancing tank armor within a decade of the war's ending, has become a historical curiosity. Fewer than a dozen intact examples are known to survive. One rests in the Imperial War Museum, another in the Bovington Tank Museum. They are displayed alongside Panther tanks and Tiger tanks, the machines they were designed to defeat, and one can understand only through imagination what it must have meant to be a soldier holding one of these devices while 36 tons of German steel ground towards your position through the murk of a Normandy morning. The PIAT represented something profound about industrial warfare in its modern form: the knowledge that no weapon is truly supreme, that tactics and innovation can always provide an answer to even the most formidable technology. The German tank designers, in their clever engineering, created machines that seemed to promise victory through sheer mechanical superiority. The British ordnance engineers, working from a position of material disadvantage, responded not by trying to build a bigger gun, but by thinking differently about the problem entirely. They asked not how to defeat a tank through overwhelming firepower, but how to make every infantryman a tank killer. That insight, that democratization of anti-tank capability, shaped the 20th century's understanding of mechanized conflict. What is perhaps most striking about the PIAT, viewed from the vantage point of the 21st century, is how quickly it became obsolete. A weapon that represented the cutting edge of anti-tank technology in 1944 was effectively redundant by 1950. Tank armor advanced so rapidly that shaped-charge projectiles had to be perpetually refined, reshaped, and reconceived to maintain their effectiveness. The arms race between armor and anti-armor that the PIAT briefly interrupted resumed with renewed vigor. Yet in its moment, that narrow window between 1943 and 1945 when the weapon was actually being used in combat, it represented a genuine triumph of improvisation and engineering skill under desperate circumstances. The soldiers who carried the PIAT were not, on the whole, fond of it. It was exhausting to operate, difficult to aim precisely, unreliable at extreme range, and genuinely frightening to fire because of the spring mechanism's power and the weapon's vibration. Veterans recall it as a weapon of last resort, a tool to be used when German tanks were genuinely threatening your position, not something you would choose to engage with if alternatives existed. Yet it worked. Against all theoretical objections, against all the predictions of skeptics who argued that a spring-loaded mortar could never effectively defeat modern tank armor, it worked. A shaped charged jet moving at 2,000 meters per second cares nothing for your doubts.
The legacy of the PIAT extends far beyond the mere accumulation of tank losses. It demonstrated that innovation need not flow from the side with superior resources, that sometimes the greatest breakthroughs come from necessity and desperation. It showed that a weapon can be simultaneously crude and sophisticated, mechanically simple, yet tactically complex in its employment. It proved that the soldier with a rifle and a grenade, believed obsolete by tank enthusiasts and armor theorists, had not yet been made irrelevant by the machine age. That lesson, learned in the hedgerows of Normandy and the rubble of German towns, would echo through 70 years of military development, would shape doctrines and designs that endure to this day. In an age of supersonic fighters and intercontinental missiles, we still build infantry weapons based on principles that Jeffress and his team first demonstrated with a spring and a steel tube. That, perhaps, is the PIAT's significance, not in the tanks it destroyed, though it certainly destroyed some, but in the question it answered. How do you fight back when the enemy seems to have all the advantages? You innovate. You think differently. You build a weapon that nobody quite believes in until it starts destroying tanks.